Hey peeps, today we're going to do the bundle. So if you look to this way, I feel like yours would be different than mine. I don't know. Okay, so you need to get on the Scantron if you have Scantron app if you haven't already. It looks like a tower on the app. You're going to enter in your site ID. Okay, it's on the board. Then your student ID. It's going to give you a little green box that says check if it's you. Okay, click yes if that is you. If not, go back. And then it's going to ask you, do you allow pop-ups? You need to hit yes. You're going to enter in the test ID, make sure that it's the geometry period 2, 1. And then when you finish, okay, before you click the very last screen, okay, you can turn in your test, but you need to take a screenshot and or just memorize your score, okay? If you take the screenshot, get on Canvas, there's an assignment titled Bundle. It'll be assignment number 10. It says Bundle on there, and you can upload that picture of your score, or in the text box, you can just write 16 out of whatever, okay? I don't know how many questions are on here, but, and submit that, okay? And that's how I can grade your bundle from home. So make sure that you do that. That's probably the most important part. All right, so hopefully you are ready to go. If you're not, pause the video, okay, and you can keep going, okay? So number 1, okay, I want you to find the missing length. By the way, we're not even to this section yet, so most of these I'm just going to give you the answer for. A couple of them I'll work out so you can see because it's close to where we're getting to, but we just are a little behind. Okay, so I want you to find the missing length. The triangles in each pair are similar, okay? So there's really 2 triangles in this. Right here is one, this black one, okay? And then there's this red one, okay? It's a triangle inside of a triangle, okay? And so we call those similar triangles. And so they want you to find the missing length, this question mark, and you can do that by working out some math because these triangles are related, but it is going to be A33. Look at 2. Okay, so 2 says solve for x. The triangles in each pair are similar. So we're given these 2 triangles, okay? And it says triangle ABC, which is this bottom one, and triangle KML, okay? And by now you guys should be able to look at these and say, well, and before we were looking at these and saying, well, this means that they are congruent, okay? Well, this other, if you take away that equals on the bottom and you just have the squiggly, that means similar, okay? And so they're congruent means the same shape and size. And we talked about how it could fit into a puzzle piece, into that one empty puzzle spot. These are similar, so they could be the same puzzle piece. They could be the same puzzle piece. Mine looks like a gingerbread man, I feel like. Okay, they're the same shape. Okay, we're gonna pretend like those are exactly the same because they are. My killer drawing. They're the same shape as far as like, we could say it's a gingerbread with a head and 4 little arms or something. But one is a bigger size. It's on a different scale. And so those are similar, but they are not congruent, okay? So congruent and similar do not mean the same thing. And so we can set these up. Since we know that they're similar, they have a ratio. And so we have AB, okay, AB, which is going to be this side, is 55. So we can say is 55, okay? And we know from our congruency stuff that KL, okay, matches up to AB. So KL is X plus 5. And this is how we write them, okay? If they're congruent, we can, or similar, we can write one over the other. And so then we can say, well, what else? Well, I got LM, which is the second and third spot, is going to be congruent to BC. So BC is 77 over, and we got the second triangle is going to be 21. Gosh, I can't write today. It's getting late, getting tired. dinner night? No, I don't. I want to go home and go to sleep. Okay. So what we do, and it's probably been a while since some of you guys did this, but you cross multiply, and then you can divide. So you cross multiply. So you got 21 times 55. Okay, is going to be 155. And then for this one, we could say 77, and you're really timesing it by x plus 5. Okay, I want you to think, well, how do we get rid of parentheses? Okay, and I would definitely pay attention because this is where we're going. Okay, how do we get parentheses? Well, we need to distribute. Okay, so I have 1155 is 77x, and I got 77 times 5 is going to give me plus 385. Okay, and I'm trying to solve for x. Okay, so what needs moved? Okay, well, this 385 has got to go. It needs to be moved over here. 385. Okay, so for that one, I'm going to get 770 equals 77x. Okay, I'm trying to get 77 by itself, or the x by itself. Okay, so I need to move that 77. So how do I do that? Well, I'm going to divide by 77. Divide both sides by 77. So I have x equals 10. Okay, which is C. Okay, and I want you to think about something. If we look at this picture, if x equals 10, okay, that means that we can plug in 10 here, which is going to make this side 55. And does that look all right? So between here and here, there's 20 units between these two, and there's 6 units in between these two. And so you can see that if it was like 100, obviously that's not similar, okay? They should be somewhat close to the same-ish number, okay? So make sure that your number makes sense. Let's look at the next one. Okay, so that one was C, 10. The next one is the same thing, okay? And so we're gonna run through it a little bit. So I know I have 2 triangles, this one and this one. Okay, and so I have GH. So we can draw our 2 things. GH is 40, or GC is 44. And for the other side I'm gonna have, because they gotta go in both on the top, triangle 1, is 52. And now I just need to figure out, well, what matches up to GC? Well, GC is right here, so it's going to be CD. So this one needs to go under the 44, so 14 plus 7x. Okay, and then this side is going to get 91. Okay, and so we're going to cross multiply and divide like we did earlier. So you multiply across, and then you have to divide this stuff out. So 44 times 91 is going to give you 4,004. And then you take 52 times the bottom, so it's going to be 14 plus 7x. Okay, well, how do I get rid of parentheses? Okay, I need to distribute. So I got 4,004. And 52 times 14 is going to give you 728. Plus 52 times 7x is going to be 364x. Okay, and then I need to subtract the 728 from both sides. Minus 728. Okay, I'm trying to get x all by itself. So I got 4,004 minus 728. It's going to give you 3276 equals 364x. Okay, and how do I move that 364? Okay, I need to divide. Okay, and so I'm going to get x equals 9. Okay, x equals 9. And if we looked in here, you can see that these two are pretty close to numbers, and these are the bigger ones. And so it should be a bigger number, like if you plugged x back in, okay? And if you did, you would get 7 times 9 is 63 plus 14. It's going to give you 77. Okay, and so you have 77 for this side. and 91 for this side, and a 44 and 52. And so you can see that those are, two triangles gotta be somewhat similar because they're around the same size-ish. Okay, and then I'm gonna stop this and we can start the next part.